Today we're going to talk about the Pythagorean Theorem. Pythagorean theorem is a theorem that applies to right triangles. A right triangle is a triangle that has a 90-degree angle as one of the three angles. So it looks something like this. The little box is a symbol for 90 degrees. This would be a right triangle. This one would not be a right triangle because none of the three angles make a 90-degree angle. So this one is a non-example. A right triangle, there are some names that we're going to use for the specific sides that will help us with the Pythagorean theorem. The longest side of a right triangle is directly across from the 90-degree angle, and this side is called the hypotenuse. The two other sides are simply called side. The Pythagorean theorem states the sum of the squares of the lengths of the sides equals the square of the length of the hypotenuse. Okay. Now, we can write this as a formula. A side squared plus a side squared equals the hypotenuse squared. Sometimes you'll see this written as a squared plus b squared equals c squared. It's important that you know when you're using the a squared plus b squared plus c squared that a and b represent the sides and c represents the hypotenuse. Let's look at an example of how we can use the Pythagorean theorem to solve a problem. Suppose we had a right triangle and one side was 3 centimeters, another side was 4 centimeters, and we want to know the length of the side of the hypotenuse. Using our formula, side squared plus side squared equals hypotenuse squared. We would substitute in 3 centimeters for one of the sides, 4 centimeters for the other side, and we're looking for the hypotenuse. 3 centimeters squared is the same as 9 centimeters squared. 4 centimeters squared would be 6 centimeters squared. 9 centimeters squared plus 16 centimeters squared these are like terms. We can add them. We get 25 centimeters squared equals the hypotenuse squared. Now, we're not looking for the hypotenuse squared, we're looking for just the hypotenuse. So we have to have a way of getting rid of the square. We do that by taking the square root of both sides of our equation. On the right side, this leaves us with just hypotenuse. On the left side, the square root of 25 is 5, and the square root of centimeters squared would be centimeters. So in our problem, if one side is 3 centimeters, another side is 4 centimeters, then our hypotenuse must be 5 centimeters in this right triangle. Let's try another example. Suppose in this example we knew a side 6 centimeters and the hypotenuse of 10 centimeters, and we want to know the length of one of the sides. Because we have a right triangle, we can use the Pythagorean Theorem. Side squared plus side squared equals hypotenuse squared. So we have 6 centimeters, the quantity squared, plus 10 centimeters, the quantity squared. Oh, excuse me. No, that's our hypotenuse. That's the one we don't know, that side. And our hypotenuse is 10 centimeters quantity squared. Six centimeters quantity squared is the same as 36 square centimeters plus side squared equals 100 centimeters squared. Subtracting 36 centimeters from, centimeters squared from both sides of our equation, we have side squared equals 64 centimeters squared. Now again, we're only looking for the side, not the side squared. So to get the side, we need to take the square root of both sides of our equation. The square root of side squared is side. The square root of 64 is 8. And the square root of centimeters squared is centimeters. So our missing side is 8 centimeters. Another example of using the Pythagorean Theorem would be this one. If the sides of a triangle are 5 inches and 6 inches, and the hypotenuse is 8 inches, Is this a right triangle? Now, recall that the Pythagorean theorem only works for right triangles. So if we can substitute the numbers 5, 6, and 8 into the Pythagorean theorem, and it holds true, then we could say, yes, this is a right triangle. If our equation comes out to be false, then we would have to say, no, these measurements would not make a right triangle. So let's give it a try. We have 5 inches quantity squared plus 6 inches quantity squared equals 8 inches quantity squared. 5 inches quantity squared is the same as 25 square inches plus 36 square inches equals 64 square inches. Adding the left side, we get 61 square inches equals 64 square inches. This statement is not true. So this would not be a right triangle. It is another type of triangle, but not a right triangle. Remember, to be a right triangle, it must satisfy the Pythagorean theorem. Okay. Last example. This is an application problem. Televisions are measured across the diagonal. In other words, if you were to go buy a 50-inch television, the 50 inches is the measurement across the diagonal from one corner to another. A 50-inch TV has a diagonal measure of 50 inches. Using that information, let's suppose you have an entertainment center. And this entertainment center has an opening of 42 inches for the width and 36 inches for the height. What is the largest television you can purchase for your entertainment center? Okay. So we have some dimensions for our opening. Let's draw a picture of our opening of our entertainment center. Now here's our opening. We have 36 inches for the height, (42 inches for the width. The question is, what size television can we fit into that slot? Okay. Now remember, televisions are measured across the diagonal. So what we're looking for is the length of the diagonal of the opening of our entertainment center. Our opening is in fact also a right triangle, so we can use the Pythagorean Theorem. So we have side squared plus another side squared equals the hypotenuse squared. So 36 inches quantity squared would be 1,296 square inches. 42 inches quantity squared would be 1,764 square inches. And this is going to equal the hypotenuse squared. Adding these two quantities, we have 3,060 square inches equals our hypotenuse squared. Now recall, we're looking only for the hypotenuse, not the hypotenuse squared. So we're going to take the square root of both sides of our equation. And this is going to give us, on the right side, hypotenuse. On the left side, this is approximately 55.3 inches. So we could go look for televisions that were approximately 55-inch TVs or less. Now, we do have to be careful that we don't go quite as big as 55 inches, because around the outside of the televisions are also possibly several inches, and we have to take that into account. But this gives us a starting place of where to go.